Hi everyone. So today we're going to look at how we add and subtract rational expressions with unlike denominators. Okay, so we started our discussion on this topic during class. Okay, so I'm just going to do a few problems and upload the video so that you can, have the video to reference. Okay, so again, as we discussed, the first step in doing these problems that have unlike denominators is to get the common denominators, correct? So let me just copy this problem over. Negative 6y squared over 8y plus 5. And we're going to add 3 over y to the fourth plus 3 over y to the fourth. Okay? So the first thing we need to do, of course, the first step is to get the least common denominator, right? And we have to make sure that we include all of the factors in the LCD, correct? All of the factors that are present, make sure we include them in the LCD. So we have a binomial factor and we have a monomial factor. So our final LCD is going to have both, correct? We're going to have y to the fourth, and then we're going to have the 8y plus 5. All right, so in order to have that, we have to multiply both of these rational expressions by whatever factor is missing, correct? So it looks like the first one, we're going to have to multiply top and bottom by the y to the fourth, right? So multiply top and bottom by y to the fourth. And in the second expression, all right, we're going to have to multiply, excuse me, we're going to have to multiply top and bottom by 8y plus 5, right? Like so. So let's see what we get then. So we are going to get, and you know what, I think we can extend this. So let me just extend this. Erase this. Just going to rewrite this a little bit. So y to the fourth times 8y plus 5. And so let's take a look here. This is going to be negative 6y to the sixth, correct? When you're multiplying powers that have the same bases, just add the exponents, right? And then plus, we're going to have to do a little distributive here, right? So we're going to have to distribute the 3 to both terms. So now we're going to have 24y plus 15. All right, so I believe that is our final answer. There's nothing to combine up here, right? So again, get the LCD, and then once you have the LCD, then you're going to have to combine like terms on the top, right? Distributive property, right? And then add the numerators, right? And then combine like terms. Okay, like so. And if you follow these 4 steps, you should be able to get the answer readily. So again, least common denominator, apply the distributive property so that you can see what you're going to add on the top, right? And then combine like terms. All right. I'm not going to type it in, again, just to save some time. Just move on to the next problem. All right. The same idea, correct? Now, but now it's a subtraction. So what I like to always do to avoid making mistakes is I like to turn any subtractions into additions using keep change change. So in this particular problem, Let me just clear this board. So in this particular problem, I have 2k over 3k minus 7, 2k over 3k minus 7, minus, I have a 3 over 8k, over 8k. Oops. Over 8k. Okay. So in this case, I always like to change a subtraction to an addition. So keep, change the subtraction to an addition, and then change the second one into a negative expression. All right, and now we can do the same process that we did before. So in this case, we clearly see that our LCD is going to have the 3k minus 7 and the 8k in it, right? So 8k, I like to write the monomials first and then the binomials, right? Which means that we're going to have to now multiply the first one by 8k over 8k. And then the second one, we're going to have to multiply by the 3k minus 7 over the 3k minus 7. Okay? And now let's do our multiplications and then add them up. So we have 8k times 2k is 16k squared. Now distributive property here again. It's negative 3 times 3k is negative 9k. And then negative 3 times negative 7 is positive 21. There are no like terms up top, so it looks like that is going to be our final answer. Okay? Again, you can just keep it like this. As long as the directions doesn't tell you to express the answer in a certain form, that's perfectly fine. As you can see, the top is in expanded form and the bottom is in factored form. That's okay. All right, that is still the correct answer. They did not specify in the directions whether they want expanded or factored. That's fine. Okay. Later on in our future problem sets, we are going to factor everything because we can cancel like factors top and bottom. But we'll get to that. All right. That's not this yet. All right. Again, just to save time, I am just going to move on. All right, and again, same idea here. We have binomial factors. Okay, so again, clearly we're going to have two binomials in our LCD. So let's do that. So 5x over 2x minus 3. So 5x over 2x minus 3. And then we're going to have plus negative 4x squared plus negative 4x squared over 3x plus 1. Okay, so before I do that, I'm going to have to do some okay. So clearly again, our LCD is 2x minus 3 and 3x plus 1, which means we're going to have to multiply this one by 3x plus 1 over 3x plus 1. And we're going to have to multiply the back one by 2x minus 3 over 2x minus 3. Okay, so let's multiply each of them separately. We're going to have, and this is a distributive property here, right? So 5x times 3x is 15x squared plus 5x times 1 is 5x. And the back, again, distributive property, negative 4x squared times 2x is negative 8x cubed. Okay, oops, looks like there's some connection problems here. Okay, but we'll just keep working through it. Let me see if I can drag this down. I can't. And then, okay, we are back. Sorry about that. I guess we had some sort of a disconnect problem. And then we're going to have negative 4x squared times negative 3 is positive 12x squared. Okay. Now, as you can see, we do have like factors, like terms here. So it looks like the negative x8 x cubed, and then the 15x squared and the 12x squared is going to give us plus 27x squared, and then finally the 5x plus the 5x. All right. And I believe that is our addition. All right. And last but not least, let's take a look at this problem. We have 6z over 6z plus 1, 6z over 6z plus 1, minus 2z squared, minus 2z squared over 3z plus 4. Okay. So again, clearly, we have to multiply. We're going to have 6z plus 1 times 3z plus 4 as our LCD, which means that we're going to have to multiply top and bottom by whatever factor is missing in each expression. So this one is missing the 3z plus 4. So 3z plus 4, top and bottom. And this one is missing the 6z plus 1, right? The 6z plus 1. Okay, so let's do the distributor for each one. So it looks like this one is going to be 18z squared plus 24z. And the back one, oh, and by the way, I should have done this, right? Keep, change, change. So keep, change, and change. So this one's going to be negative 12z cubed minus 2z squared. Okay, and again, definitely we have some like terms going on here, but let's write in standard form. So let's write the z cubed term first. 12z cubed. Okay, that takes care of that one. And then we have the 18 with the negative 2. That makes positive 16 z squared. And then we have the 24z. And there is your answer. Okay, folks? All right, take care.